I'm on a roll. I'm riding a high, so I'm gonna go ahead and keep going. I'm gonna talk about error handling. I know that was something that I started to talk about in the last session, or at least I mentioned it, that I would get to it later, and I thought, what the heck, I'll get to it now. And now that I've had a chance to catch my breath, take a bio break, and you know, get a little help from our sponsor. And by sponsor, I say that in the solemnest way that it's a very serious situation. But I happen to have a fridge full of Coronas, so it's time for Coronas. But I want to go over error handling. So error handling is something that's built into MassTransit. When I think about a saga or something like that, durable messaging is all about being able to build resilient systems that are able to handle failures. So one of the things that I want to jump in here and do is I want to be able to do something like kill Redis, which not like literally in that sense, but I want to be able to stop the Redis server and not, it could be an outage, it could be a transient issue, it could be a network problem talking to it. But I want to be able to do that and kind of show what happens now. So I'm going to bring the website back up. Oh, that's the problem with drinking on the job, I guess. Yeah, drinking from home at a safe distance. I'm going to go back to my website here, and I'm going to try to get the order status. If I hit execute, I'm going to get my 200. Everything is good. Order is submitted. But what happens when I stop Redis? So I'm going to go over here and I'm going to stop Redis. Redis is now down. Oh, that's cute. It says bye-bye. And now I'm going to try to execute this again. Boom. I got a 500 internal server error. The sample check order request faulted, sample.components blah blah blah, saga exception on receipt of sample saga load failed. Why did the saga load fail? You can see I got a lot of information here because I just threw the whole exception out. But if I go and look at the code, I see a fail. Check order request faulted, order mistake, saga load failed. Redis is down. It's not there. It's gone. Nothing's going to happen. It's no good. So if I bring Redis back up, notice I didn't restart my service or anything, but I brought Redis back up. I go back to my web page, I execute again, and now we're back to a good running state. So I want to create a little resilience in my service. Maybe Redis was only going to be down for a second. So let's go to my service. It's the only thing that talks to Redis. I'm going to kill that. I'm going to look at the code for it. And I'm going to look at where that saga is configured, the order state machine. And I think we're at a point now where I'm going to be able to move this over to order state. Now, so MassTransit is built on top of a library called Green Pipes, and Green Pipes is a pipes and filters library that is used for all of the execution engine within MassTransit. So everything that gets called is through a filter. Each of those filters has one method called send, and within that send is the appropriate pipe context. So whether that's a consumer, whatever, it's going to be a consume context, it's going to be a receive context, any of those contexts are going to be passed around. So what I want to do is I want to go to that receive endpoint and configure some exception handling filters to handle that. Now the nice thing is this is very well documented on the website, and I can just literally go steal the code from the website that does it. But the one that I'm looking for is this one. And it lets you configure the receive endpoint to use message retry, which I might put a little bit longer time interval in here. Use the in-memory outbox, and then have my consumer. Now, if we remember, the way I'm configuring my service, I'm just calling configure endpoints. I don't have any control over this whatsoever. I'm just saying go configure the endpoints. But I actually do have control over it. And I have control over that by creating a definition for this saga. So within the order state machine, I'm going to create another class called order state machine definition. And I'm going to create this. This is going to be a saga definition. And it's going to be after the instance type, because the state machine is the behavior. The data of the saga is the order state. And then I'm going to override the configure saga method. And so the configure saga method is going to be called when configure endpoints is called. And it's going to be passed the iReceive endpoint configurator and the saga configurator. Sorry, I'll split this out a little bit. So the receive endpoint configurator as well as the saga configurator. And I can change this to do other things. For instance, if I want to add the use message retry, I can add that middleware, and I can say for retries, I want to do a intervals. And I want to retry after, let's just say 500 milliseconds, 5 seconds, and then 10 seconds. And I really wouldn't try much more than that. The way that use message retry works is any message that fails, it's going to keep the message in memory. It's going to block and use a processing slot on the receive endpoint. So for instance, if the prefetch count is 16, it's going to still use up one of those 16 prefetched message slots. And it's going to just literally just call task.delay for 500 milliseconds, 5,000 milliseconds, and 10,000 milliseconds, each time recreating the consumer, setting it all up from scratch, and actually executing the method against it, the consume method. So, it does completely tear everything down. In the case of sagas, it's going to then go and try and load the saga instance again. So if another process was running at the same time, it could try to load that saga with a different message. But the message is locked on the broker, so that same message won't be processed by anyone else. I could also add the in-memory outbox, which is going to prevent any messages sent or published from this state machine from actually going out. And the reason that's important is if I was actually publishing an event and then the state machine couldn't be persisted to disk, I wouldn't want that event to go out because the state machine isn't in the correct state at that point because the disk write failed. So it would discard any of those pending sends, responds, publishes, whatever, and then when the message retried again, those would process from scratch. That's really all I want to define here. There are other things that you can define. If I were to actually put a constructor in here, you can actually come in and do a few different things. I really don't know what they are though. So it's, I could set, I could set like a concurrent message limit. I could say that I only want to process 4 instances at one time. And it would configure the appropriate transport to do that. So let's set that just for fun. I'm going to move that over to another class. And this definition, by the very nature of being within this assembly, I'm going to then say add saga state machine type of order state machine definition by passing that definition to the add state machine. Now, if I save this out and I go out and run that service again, hopefully it doesn't explode. No explosion is good. Now, if I go back to the web browser, and go back to my little UI, this works this time. Everything is great. I'm going to try to do this quickly. I'm going to stop Redis. I'm going to go back to the website. I'm going to bring up that. I'm going to hit execute. We know it's trying. We know it's trying. We know it's trying. We're going to hit play. We're going to bring Redis back up. And it was able to recover, I believe. Isn't it? Let's hold on. See if it does. I think it did. It's really hard to see. Yeah. There it is. There's the send. Yep. Good. Yeah, because there was that one. So let's go here. Let's kill this. Let's call clear. Let's do the run. We know that it's caught up. We go over here. Stop Redis. We go to the website. We hit execute. We know that it's waiting. Nothing's happening here. We go here. We start Redis. Hopefully we did it within 10 seconds. And we didn't. So in this case, we didn't actually get it in time. Because the retry failed, it failed to retry. And, oh, wait, no, that's a warning. So it output the warning that it failed, but it didn't output the error because we were within the 10 seconds. Okay, so the first time it failed to connect to Redis, but it retried 10 seconds later, because you can see I got the 200 here. I didn't get the 500. If my error warning, if my output layer for logging was error, I wouldn't have seen this, because this is just, it's a notice that it's actually retrying. If it had actually failed after the retries were exhausted, it would actually say r-fault, and it would actually publish the fault like it would have done otherwise. As it is, this is just a warning to say, hey, I failed, but I'm going to try again. And then when it tried again, it was able to use the existing Saga instance. It was able to receive the message, and then it actually published out. And you'll notice the ordering here is a little different, because the receive completed, and then it actually sent the message. So the outbox kept that message sent, and then sent the order status message. And now, of course, if I come in, it's going to transfer immediately because I have access to it. So that's how we add error handling to a Saga. We could also add it to our consumers. Just like we have the submit order consumer, we could create a, that's going to drive me crazy if I keep doing that. We can create a consumer definition, class submit order consumer definition. And the name doesn't really matter. It isn't trying to match it by name. It's matching it actually by the type. So in this case, submit order consumer. And I have the same type of levels here. I could override the configure consumer. I could put things on the middleware. For instance, this one I could say endpoint configure.use message retry. I could do something very similar. I could do this one of, let's just say I want to do 3 retries every second. Great, awesome, grand. If I wanted to do something specific to the config consumer, I could configure that as well. So the way the middleware works is it's all a pipeline. So the receive endpoint has its configuration, and then once the consumer is created, it has its own pipeline. So for instance, if I go to consumer configurator dot consumer message or message, like I could add a pipe specification here. Like I could say use filter, and the filter type that it's going to want in this case is going to be a consumer filter, because the way the pipe is. So use message retry, this is actually going to register an observer, and every message type consumed by the submit order consumer is going to have a message retry filter added for it. So, I mean, one of the very basic filters that's out there is actually use execute async, or just use execute. And I could just say context, and I could say, I don't recommend this, but you could just say console write line, hello, context dot, in this case, it's a consume context without a message type. So it really isn't a whole lot of value, but I could use the source address or anything that's a header on there. If I wanted to deal with a specific message, I could say dot. I could use the consumer configurator, and I could actually configure the pipeline for that specific message. And I could say use execute context. And now if I say context.message dot, I have access to the message because I've defined the message type. So another option that we have there for throwing in middleware. A lot of the middleware is documented on the website under the middleware section, but we'll put the use retry there for now. I don't need an outbox here because I'm not doing anything with the database, although, I certainly could. I don't know why I would, but. And that's the submit order consumer definition. I could also do something really kind of fun, like if I wanted to just come in here and say, you know what, CTOR, I could say endpoint name equals Frank. I could change and force an endpoint name for a particular consumer. That's one way to override the default name formatter. Again, I have the concurrent message limit. I have that's always there. So there's a number of different things you can do in a definition. Some of them are cool. The concurrent message limit. The reason it's concurrent message limit is because each transport is going to do that differently. So the transport might say, oh, well, if you have a concurrent message limit of 10, I'm going to only ever run 10 concurrent consumers, but I might set the prefetch count to the transport to 16 so that I can read messages quick and keep the pipe full versus having to have a lag between the time I acknowledge one consumer and then deliver a message to another one. So I'll just leave this here because it's fun. Why not? Keep that going in there. I haven't get to see these services here, so I'll give myself a little more window space. Some of the other things that we can do with middleware, if we go back to the order state machine definition, so I have the message retry and I have the in-memory outbox. Another fun thing I can do is I can actually come in and say, create partitioner. And let's say that I only want to have 8 messages at a time. So if I wanted to partition messages, and the thing is this only happens within the single instance. So the usefulness of this is kind of limited. But it will allow me to actually create a way to order messages using a partition hash. So I could actually come in here and say endpoint configurator dot message. Wait, no, saga configurator dot message and like order submitted. And for that message, I could say use partitioner partition. And I also have to tell it how to do that. So m.message.order-id, like if I wanted to partition it so that in the particular order, or if I only wanted to process a single customer at a time, I could do customer number, I could do any of those. Again, this is just per instance. With Conductor, you'll actually be able to do this client side using a consistent hash ring, but that code isn't even written yet, so don't get too excited. But it should be coming soon because Conductor is getting closer every day. But yeah, just kind of showing you some of the things you can do within those definitions. Yeah, so that's kind of fun. The key thing being is how do you actually specify errors when you're configuring a saga using the add saga definition. So that's kind of a good way to do it, especially since you don't have control of the endpoints. If you did actually have control of the endpoint, like for instance in this bus with configure endpoints, you'd never mix the two of these, but if you did want to just create a receive endpoint and call it something else, and then you wanted to have that endpoint for configuration, you could say n dot use message retry r dot exponential, and it has some parameters like I only want to retry 10 times. Time span dot from seconds 2 to time span dot from seconds 30. What would I forget? What's the error? I don't even know what the error is. 4 parameters. 4 parameters for what? Oh, there's like a delta. Yeah. This thing confuses me. Just say 3-second delta, whatever. Exponential retries mess with my brain, so I don't really deal with it too much. But I do use them quite a bit because they are nice, because the longer the failure, the better. But yeah, I could configure that, but if you're using configure endpoints, I wouldn't necessarily say go crazy with those. And that's all a lot of stuff that's defined under green pipes. So that's some pretty basic error handling. The one reason that you would really want to do that kind of error handling with a state machine is because of concurrency modes. Now I know where I'm configuring the state machine. I didn't specify any details around the concurrency, but I do actually have some options within the Redis repository here. I can set the concurrency mode. I can set it to optimistic or pessimistic. If I set it to pessimistic, it's going to use a Redis lock to lock the saga ID. And if it can't get the lock, it won't process the message. Whereas with optimistic, it's going to use that saga version to try to update afterwards. So, it's really going to depend upon the event design around your state machine. If you have a state machine that just absorbs one event, always make these optimistic because you're never going to have a conflict. If you have a state machine that gets a lot of different events that are all published up front and could possibly all arrive at one time, it might make sense to set it to pessimistic just to lock that grid. And just to prevent the conflicts. Using the partitioner is also great for that because if one instance is processing all those messages, they'll get serialized such that you won't see concurrency errors as often and won't see a lot of lock waits. So just something that's kind of fun to do. Again, if you were using a database remotely, you can change the key prefix, the lock suffix, lock timeouts, all this stuff. The database configuration, Redis takes a string, so like I said before, you could do the local host or whatever. It just gets passed to generate a configuration options, not parse. So it's just stuff to make it easier to configure. So that was kind of short, especially given the early ones, but I wanted to cover some of that error handling because I did mention it and I'm not tired yet. So I figured that would be kind of fun to go over. Oh, I did want to make sure that this error handling was actually kicking in. So if I go to RabbitMQ client and I look at the queues and I look at order state, you see I actually have an order state error because I did have messages that errored early on. So when an error is thrown in MassTransit, if the message can't be processed, it will eventually move it to an error queue. And by default, that error queue is called _error. So in this case, it looks like I have two messages that were there. One of them looks like a order submitted message. So this is when we had like the duplicate submission thing, or we had it in a state that it wasn't handled because it had received in. And you can see MassTransit, when a fault actually happens and it ends up in the error queue, it adds some additional headers, such as the consumer type. In this case, it was the state machine, the exception type, unhandled event, a message, the message type that faulted. In this case, it was order submitted. And then we even throw a little stack trace in there so you can see where it's at. Of course, most of this is internal autonomous stuff, which isn't super useful, but you get the point. It couldn't raise the mess. If this was your user code, it would have your user call stack in it. In this case, it was because the state wasn't valid. But all of that information is available out there, the original message as well. If you're using RabbitMQ, you can use something like Shovel to punch these messages back into the main queue. I don't know if Shovel is included in the admin tools by default. I don't think it is. Or there would be a little shovel box down here. Oh, move messages. To move messages, Shovel must be enabled. Yeah, and Shovel's not there. But if it was enabled, I could just move those back to the queue. They would be immediately picked up by that state machine. And since the state machine logic has been fixed to handle item potency, it would just take that message and then actually ignore it out. Yeah, so that's kind of fun. The other thing here, I want to remember about this. Is this one of those expiration ones? Yeah, see, this one does have an expiration time. By default, when messages move to the error queue, we clear the time to live in the broker. So the broker isn't going to delete this message automatically because, the time to live on it. But because it has an expiration time on here, if it was read to be processed and that expiration time is expired, the transport may discard it. It may look at that timestamp and say, man, that was so long ago, this message shouldn't even be here, and it would throw it away. But that's going to depend upon the transport and whether it was coded to check that. So that's what a message looks like in the error queue. The other thing you'll see is that two exchanges were created in RabbitMQ. One is called fault of T, and generic ones get written out with these little separators, but I have a MassTransit fault of sample.contracts order submitted. And what's going to happen is MassTransit is actually going to publish a message called fault of T, in this case, order submitted. And that message is going to include the exception information as well as the original message that faulted. So if you created the consumer on that fault, you could actually use that to do something. It's also bound to MassTransit.fault, which is just the basic non-generic version of fault. and there are no bindings there. The reason it's bound that way is because MassTransit supports polymorphic messaging. So if you publish, with RabbitMQ, it supports polymorphic messaging. So if you publish a fault of order submitted, but you only subscribe to a fault, the non-generic version, you will get a copy of the message because the message implements that fault interface. So if you only subscribe to fault, you'll be able to get that. So kind of nice feature there. So I think that's enough for covering for errors for now. I just wanted to kind of cover that in and while it's fresh in my mind. Oh, the other thing I wanted to look at is while the service was running with the order state, you can see the consumer, it only has a prefetch count of 4. And in this case, that's because I specified the concurrent message limit of 4. So it read that value and said, yeah, that's low enough. I'm going to go out and actually just put that as the prefetch count as well. So if you had multiple instances and 100 of those order submitted messages came in, each instance would only pre-read 4 of those at a time. So it would get a little bit smoother load balancing versus queuing them up on each individual instance in memory, waiting to be processed. Now, if your database can handle that level of concurrency and can process those, rock on, set it. I mean, we have some consumers in production systems that are running 100 concurrent consumers because the database, it's just doing inserts and it's actually faster to do a whole bunch of them at once versus queuing them up 1, 2, 3, 4 and dealing with the round trip time of that interaction. So, all right, that's what I got today. Oh, sorry, that was probably really loud. I have the window kicked in. Yeah, so that's where that's at. That's exception handling. One extra bonus video tonight since I had it in my head and I was kind of thinking about talking about it. So again, thanks for tuning in. Probably nobody watching right now, but that's all right. It's late. Anyway, thanks a lot. Talk to you later.